So this is a hot knife that we ordered online and then had shipped here a while back. And it comes with a couple of like straight blades that you can connect in between here. But we decided that we wanted one that was a little more suited to our purposes. So I basically cut one of those blades in half and then bent that to the shape of one of the standard conduit boxes. So as you can see, it fits the depth perfectly. Originally, I was trying to, take this off and then put another bent piece of metal there that would be the exact width of the channel for the conduit, but that ended up being a little bit too difficult to switch back and forth. So I decided to start using this instead. And then for the channel, I just go horizontal or then sideways to keep the depth so that when I cut in with the hot knife, it goes the correct distance back to be able to hit the knockouts and run the conduit at that depth, because before it was a little bit off, and so it was a little bit harder to get that consistency. To mount the boxes in the ICF foam, originally I was measuring off the concrete floor to mark out my pattern on the wall, but I quickly realized that our floor is not entirely level in some areas, so I found that it was easier to take our laser level and then set all the boxes to that laser, so at least they were level relative to each other, if not to the floor. For the plastic ICF stud webbing in between, I ended up using a combination of the multi-tool and jigsaw to cut those, and that seemed to work out pretty well. You can see over time my technique definitely got better as far as keeping my channel a little more narrow. And then the back of the boxes were mounted to the concrete. I used Tapcons, 1 to 2 per box, depending on where it was located and how difficult it was to get in there.
So this is your basic load panel. These spaces in the middle are I guess these bars are the plug-on neutral, and as you can see, they connect to the neutral bars. Unfortunately, in a typical load panel where you're coming directly out of your meter base and into the panel, you would have your ground and neutral bars connected at the main load panel, but I'll be installing an automatic transfer switch, and that's going to be my primary disconnecting means. And so you're not allowed to connect the neutral and the ground bars after your primary disconnecting means. So the neutral and the ground bar will be connected in the automatic transfer switch, and I have to disconnect them in this load panel. There may be a way to do it by removing one of these screws. I'm not sure. It really looks like no matter what, these bars end up getting connected to these neutral breaker bus bars. So generally, what you'll do is you can install a ground bar somewhere along one of these holes, and it will tile your grounds to that one point, and your neutrals will be physically separated from the case. And I think that's what the screw does. Yeah, this is the box binding screw, so if you take the screw out, the neutral bar is then isolated from the case, which is what I'll need to do. Square D makes these nice sleeves for going over the feeders, and these are really handy because when you're pushing new circuits into the box later, you're a lot less likely to hit one of these big lugs and zap yourself. So I like these a lot. And then, like any panel, it's got a main breaker on it. This is actually something you want to look for when you're choosing a panel. You have to make sure that if it's going to be your main house panel, that it has a circuit interrupter on it, because a sub panel will just have these lugs going directly to the bus bars and won't have a circuit breaker in it. And then this box is just the value, the free breakers. These things are the non-arc fault circuit interrupter type, and they're usually very cheap. They're like $5. I guess I untripped that one, but one big difference between the Homeline and the QO, besides the build quality, is the QO has the nice tripped indicator, so this little window will turn red if your circuit breaker is tripped. These also snap on really quick type, really nice. There's another option. You can get a bolt on type, and I think that's similar to the QO. I think it's called like QOB or something like that. But yeah, they just snap into place, a little bit of force, and then they're in, and then just fill them up. Today I'm pulling they're not actually service conductors, they're feeder conductors from where my transfer switch is going to be on the wall. under the house and into my utility room. So because this is 200 amp service, there's a special section of the NEC that says if a residence is fed entirely by these feeders, you can downsize them from the typical 250 kcml to 4-aught. So I've got 4-aught, 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 2-aught. So I got 3 4-aught aluminum conductors and a 2-aught ground. I need to pull a ground because my actual service disconnect is going to be the transfer switch, not my load panel like it would typically be. So I got to pull a ground. I don't bond my load panel in my house to ground because it's not the service disconnect. So they don't have them marked. One of them is white for neutral. These guys, I guess it doesn't matter which one's which. But yeah, this stuff is like $7.50 a foot. So 50 feet of it is like $400. But it's pretty hefty. Got it at Menards. And we're gonna see if we can get it through the hole. As big as my hand. So one quick note, Menards calls this stuff mobile home feeder cable. I don't really know why. But what you really need to look at to make sure you're getting the right stuff is look at the actual wire rating itself. And it's usually it's rated as multiple different things, and you basically pick the one that you need, and we need USE2, underground service entrance cable. So that tells me it's the right stuff. It's pretty dark back here, but this is where my feeders come out of the ground and go to my load panel. And quick tip for fishing a pole line through, because my fish tape will make it, but it's a pretty long run. So the easiest way to do that actually is get yourself some 550 paracord or any kind of light rope, and then tie it to a part of a bag and just kind of stuff it down the hole a little bit. And then I got just the head of my rigid vacuum in below. So I'm going to turn that on, you're not going to hear anything, and you'll watch it suck the bag right through the line. Trip the breaker. But yeah, it's all the way through. And make sure you tie it off something, otherwise you'll lose the rope. So you can follow me into the other side of the trench. And there's our bag. So I'm going to pull it out and tie it up real good to the cables we got. Okay, so I've got my service entrance conductors pulled into my main panel. And now you got to cut the insulation off. These are the 4-aught cables. This is just 2-aught ground. And how a lot of electricians will do this is they'll take the cable and they'll take a box out and they'll cut around it, and then you strip the jacket off, and they should be able to peel the jacket off. I've done that a lot before. I did that this time, and on the first cable I slipped and sliced, I basically filleted my finger and got 4 stitches for it. So don't do that.
Which is why I said don't even demonstrate.
Suck it up and buy the proper tool. This is from Greenlee. This is an expensive one. No matter what, they're expensive. This one's like $80. You can get them for as cheap as, like, I guess you can pay $30 if you go really cheap. And it's basically a blade that hooks on the wire like this. And all you got to do is you wrap it around. It's basically the same thing you'd be doing with a knife, but you go around a few times, and then you turn the blade 90 degrees and pull this way, and it does a vertical slice. And then you can just grab some pliers and you can peel the jacket off. I don't know if I actually got that horizontal slice quite thin enough, but yeah, it just comes off, and then there you go. Good to go. So we got our transfer switch mounted, and our meter. It's really hard to get a hold of one of these, but we finally did. It's got to be a local utility approved meter, and so depending on what county you're in, you can look up your electric service provider, and they'll have like a list of all the meters that they'll run power to. So you now to make sure that you get one that is approved for your area. Usually your local hardware store will only stock those, but just check the list to make sure that the part numbers match, because they're very picky. I got my 3-inch conduit coming up out of the house. There's a real bear to get the wire into that LB down to the ground. This 4-aught didn't want to take the turn. But now I'm up and into my transfer switch. This is a service rated disconnect. So my actual like service disconnect is this 200 amp breaker here. And so I treat this more like a main panel, and my actual main panel is more like a sub panel, where this is the point of service where the neutrals get bonded to the ground, and then I don't bond to neutral in my actual load panel, and that's why I got to pull an additional 2-watt green ground. So that's pretty much it. All I got to do is I got to get my my service, my utility service will come in through the top, and then my customer load, or well, my main panel will connect down to here, and I'll bring the ground up over and connect these big neutral lugs. So it should be pretty simple. Yeah, this is just really one of the many problems of doing a vaulted ceiling. I didn't understand when we got the roof trusses quoted why it really wasn't any more expensive at all to do a vaulted ceiling. So I didn't really understand why everybody didn't do it, because it just gives you so much headroom and it looks so open. But it turns out it makes all the other trades more complex. Like framing these walls in took forever because we had to do every single, perpendicular wall on a template because none of the studs are the same length. The straight walls were extremely heavy, especially this 2x6 one, which has got plumbing in it and stuff. So that's why I did 2x6s. 2x6s are a little straighter too. So with a tall wall like this, it's really important to get straight lumber. A lot of people like to use parallel strand lumber because it's straight just for these tall walls, because you will see any bows or imperfections. But yeah, the dormers, the functional dormers were cheap to put in. The trusses were cheap, but it just wreaks havoc on HVAC, plumbing, even electrical is kind of a pain because we can't get conduit through there. So that's where the cost comes from.
But they're pretty.
So we hung our high bay light, and it's actually way brighter in here now. Should have done this a long time ago.
Look at us getting fancy. So originally we were storing all of our tools in the pantry, and I need to get in there to do some of the electric. We have a massive pantry. A lot of it's going to be storage. But I cleared off one of the storage shelves that we had in our garage and made ourselves a little tool shelf. How does it feel to be 28?
Nominal.
Nominal?